Now we will continue with the preparation of alcohols. Next method is from aldehydes and ketones. See here, aldehydes on reduction with hydrogen in presence of a catalyst, and the catalyst you can use is nickel, platinum or palladium. What is a reduction? Addition of hydrogen or removal of oxygen. So here one molecule of hydrogen is added or 2 hydrogen atoms are added. So what will you get? RCH2OH. That means you are getting a primary alcohol. So aldehydes on reduction you are getting primary alcohol. So you can use hydrogen in presence of catalyst, or you can use sodium in presence of ethanol, or lithium aluminum hydride, or sodium borohydride. So in all these cases the hydrogen which you get is what? Nascent hydrogen, that is the hydrogen is evolved from the reducing agent. So these are the reducing agents which can be used to reduce aldehyde. So aldehyde on reduction you are getting primary alcohol. Now see here, if I take CH3 CHO, this on reduction with lithium aluminum hydride, 2 nascent hydrogen, you will get what? CH3 CH2OH. So you just remember, a primary alcohol on oxidation you are going to get what? A aldehyde. So is it clear? The reducing agents which can be used to reduce aldehydes is hydrogen in presence of catalyst nickel, platinum or palladium, or you can use sodium in presence of ethanol, lithium aluminum hydride or sodium borohydride. Now lithium aluminum hydride is a good reducing agent. Why? Because it will not reduce double bond. That is, suppose you have an unsaturated aldehyde, CH3 CH double bond CH CHO. This on reduction with lithium aluminum hydride, you will get an unsaturated alcohol, CH CH2OH. So is it clear? So these are the reducing agents which can be used to reduce aldehyde to primary alcohol. The same reagents can be used to reduce a second ketone to secondary alcohol. See here, R C double bond OR. This is the general formula for a ketone. So here also you see one hydrogen will add to this carbon and one to oxygen. So again you are getting which alcohol? Secondary alcohol. The reagents used are the same: hydrogen in presence of catalyst, or lithium aluminum hydride, sodium borohydride, or sodium in presence of ethanol. You can use any one of this. So you will get what? A secondary alcohol, CHOHR. So is it clear? So aldehydes and ketones on reduction you are getting corresponding primary and secondary alcohol. Next you see a carboxylic acid. Carboxylic acid on reduction also it is converted into a primary alcohol, but the reducing agent which you can use is only lithium aluminum hydride or diborane, followed by acidification. So this is the reducing agent which can be used to reduce a carboxylic acid. So a carboxylic acid is also converted into what? Primary alcohol, but you can use only what? Lithium aluminum hydride or diborane. You can't use hydrogen in presence of a catalyst, or you can't use sodium borohydride, or you can't use sodium in presence of ethanol. So hydrogen in presence of a catalyst, or sodium in presence of ethanol, or sodium borohydride will not reduce a carboxylic acid. Is it clear? The only reagent is lithium aluminum hydride or diborane. Next is esters. Esters are reduced by lithium aluminum hydride or hydrogen in presence of a catalyst to corresponding primary alcohol. See where the bond is breaking? The bond will break here, and you are going to get RCH2OH plus R prime OH. So is it clear? So esters are also undergoing reduction and you are getting which alcohol? Primary, but the reducing agent which you can use is lithium aluminum hydride or hydrogen in presence of a catalyst. Sodium borohydride will not reduce carboxylic acids and esters, and sodium in presence of ethanol also. Okay, is it clear? So esters on reduction you are getting primary alcohol, carboxylic acid also on reduction you are getting what? Primary alcohol, aldehydes on reduction also you get primary alcohol, and ketones on reduction you are getting which alcohol? Secondary alcohol. Sodium borohydride will not reduce carboxylic acid and esters. Even hydrogen in presence of a catalyst also will not reduce what? Carboxylic acid. So, that should be very careful. Esters and carboxylic acids not reduced by sodium borohydride. Then carboxylic acid is also not reduced by what? Hydrogen. Carboxylic acid is also not reduced by hydrogen in presence of a catalyst. Now, the best reagent is lithium aluminum hydride. Why? Because if it is unsaturated also, that can be reduced, it will not undergo reduction, you will get a unsaturated alcohol. But lithium aluminum hydride is a very costly reducing agent. So, these are the methods for the preparation of alcohols. Next, we will see the methods of preparation of phenol. The first process already we have discussed, dose process, that is chlorobenzene when treated with sodium at 623 Kelvin and 300 atmosphere pressure followed by acidification gives you what? Phenol. Okay. The next method is from benzene diazonium chloride. See, benzene diazonium chloride or benzene diazonium salt when warmed with water or on treatment with HCl gives you phenol plus N2. So, here you get a conversion aniline to phenol, aniline to conversion aniline to phenol. So, how will you convert aniline to phenol? First you will convert aniline to benzene diazonium chloride by diazotization, then you can warm it with water, you get what? Phenol. So, is it clear? So, diazonium salt on warming with water or in treatment with HCl gives you phenol. Next method is from benzene sulfonic acid, SO3H. This is benzene sulfonic acid. This when treated with sodium hydroxide, we get what? The hydrogen atom will be replaced by sulfonic acids, sodium atom. See, sodium benzene sulfonate on reaction with again sodium hydroxide followed by acidification gives you phenol. So, actually how this reaction happens is, see here sodium benzene sulfonate reacts with 2 molecules of sodium hydroxide, okay, and from here 1 molecule of sodium sulfate and 2 molecules of water is eliminated. So, what is left? Na, sodium phenoxide. So, actually the reaction is happening like this. Sodium benzene sulfonate is converted to sodium phenoxide, which on acidification you get back what? Phenol. So, got it. So, benzene sulfonic acid reacts with sodium hydroxide to give you sodium benzene sulfonate, which on reaction with sodium hydroxide and HCl gives you phenol. Commercially, how phenol is prepared? Commercially, phenol preparation, okay, or industrially, how do you prepare phenol? It is prepared from a compound called cumene. This is cumene. What will be its name? Isopropyl benzene, that is known as cumene, okay. This on oxidation with air is converted to cumene hydroperoxide. Peroxide means how many oxygen will come? 2, and it is adding to the secondary carbon, okay, this carbon. So, this is known as cumene hydroperoxide, and this on treatment with dilute sulfuric acid. See here, from here acetone is removed, CH3, CO, CH3, then what is left? OH group attached to the phenyl group. So, you are getting what? phenol, OH, phenol. So, is it clear? That is cumene on oxidation with air gives you cumene hydroperoxide. Peroxide means how many oxygen will be there? 2. So, the mechanism of the reaction is not there. So, from this a molecule of acetone is eliminated and this OH group attached to the phenyl ring. So, you are getting what? Phenol. So, these are the methods of preparation of what? Phenol. One is dose process from chlorobenzene, reacts with alkali at about 623 to 300 atmosphere pressure, followed by acidification to give you phenol. Then benzene diazonium chloride when warmed with water or with HCl gives you phenol, and then benzene sulfonic acid on reaction with sodium hydroxide followed by acidification gives you phenol. And commercially it is prepared from what? Cumene. Cumene on oxidation with air gives cumene hydroperoxide, which on treatment with dilute sulfuric acid gives you what? Phenol. So, these are the methods of preparation of phenol and alcohol. Next is physical properties of alcohol and phenol. Physical properties of alcohol first. And the first is the first 3 members. The lower members are liquids, volatile liquids. Lower members are volatile liquids. Then higher members are waxy solids. So, this is the first property. Now, the second one is lower members, that is up to 3 carbon atoms, are soluble in water. Why they are soluble in water? Because they can form what? They can form intermolecular hydrogen bonding. So, is it clear? The lower members are, that is up to 3 carbon atoms are soluble in water, and they can form, that is why, because they can form hydrogen bond with water, intermolecular hydrogen bond with water. Now, the higher members, they become insoluble in water or they are immiscible in water. Why? Alkyl, as the size of the alkyl group increases or the molar mass of the alkyl group increases, they act as an obstacle for the formation of what? Hydrogen bond, or they mask the formation of hydrogen bond. Why do they mask the formation of hydrogen bond? Because alkyl groups are what in nature? Hydrophobic in nature. Alkyl groups are hydrophobic in nature. So, that is the reason why they mask the ability of alcohol to form hydrogen bond with water. So, is it clear? Then the third one is boiling point. Alcohols have high boiling point. Why? Alcohols can form intermolecular hydrogen bond. So, the boiling point is high. When you compare haloalkanes, then hydrocarbons and ethers, when you compare them, alcohols have higher boiling point than hydrocarbons, haloalkanes and ethers of same molar mass, even in case of aldehydes and ketones also. If you compare alcohols with ethers, aldehydes and ketones, then hydrocarbons and haloalkanes of same molar mass, alcohols will have higher boiling point. Why? Because they can form what? Intermolecular hydrogen bond. So, that is the reason why alcohols have high boiling point. Then among isomeric alcohols, what happens? Boiling point decreases with increase in branching. Why boiling point is decreasing with increasing branching? Because the molecules assume what shape? Spherical shape, and then what happens to the surface area? Surface area decreases. So, what happens to van der Waals force of attraction? The van der Waals force of attraction also decreases. So, the boiling point decreases. So, what is the order of boiling point of primary, secondary and tertiary alcohol? The order of boiling point for primary alcohol will be the highest, greater than secondary alcohol, greater than tertiary alcohol. So, is it clear? Because as branching increases, the molecules assume spherical shape, and therefore what happens to the surface area? Surface area decreases and hence boiling point decreases. So, these are the physical properties of what? Alcohols. Next is physical properties of phenol. One, it is a colorless liquid. It's a colorless liquid, but you see here, if you keep it for a long time, you see in laboratories and all, you see the color of phenol is brown in color. Why? Because when it is kept for a long time, when exposed to air or sunlight, it gets oxidized, that is it undergoes oxidation. So, that is the reason why its color becomes what? Brown, that is it is converted to what? Quinone. Actually phenol is what? A colorless liquid, but when exposed to air or sunlight, it gets oxidized to what? Quinone, and that is the reason why it is brown in color. Then number 2, it's phenol is partially soluble in water, due to the formation of hydrogen bond with water. So, they are also able to form hydrogen bond with water. So, it is partially soluble. Then number 3, the boiling point of phenol is high due to intermolecular H bonding. So, these are the physical properties of phenol. It is a colorless liquid. When exposed to air or sunlight, it gets oxidized to quinone, that is why its color becomes brown. Then it is partially soluble in water due to its ability to form hydrogen bond with water. Then boiling point of phenol is high due to intermolecular hydrogen bonding. Next is chemical properties of alcohol. Okay. Listen carefully, it is very important. One is alcohols act as nucleophile. What is a nucleophile? A species which can give electrons. See here, just writing a general formula, alcohol. So, why is alcohol acting as nucleophile? Because oxygen is having what? Lone pair of electron. So, it can donate electron to a species which is deficient of electron. So, it can give electron to what? Electrophile. I am just making an electrophile here. So, this carbon is what? The carbocation is deficient of electron. So, this can give electron. So, it is giving electron. So, what will be formed? R CH2 OH C. Okay. Now, who is going to get the positive charge? Oxygen. Why? Oxygen has given its electron to the carbocation, that is the electrophile. Now, during this reaction, the oxygen hydrogen bond cleavage takes place. So, is it clear? When alcohol acts as a nucleophile, the oxygen hydrogen bond cleavage is taking place. So, the first chemical property of alcohols is it can act as a nucleophile, and this comes as mechanism in the preparation of ethers. Is it clear? So, why is alcohol acting as a nucleophile? Due to the presence of lone pair of electron on oxygen atom. Second one, you see here, I am just writing the same alcohol, and to this I am going to add a proton. This proton is deficient of electron. So, what are you going to get? R CH2 OH H. This is known as what? Protonated alcohol. This is known as protonated alcohol. So, what can you say? The protonated alcohol, here oxygen is having what charge? Positive charge. That means it has become deficient of electrons. So, you can say protonated alcohol acts as electrophile. Protonated alcohol acts as electrophile. So, is it clear? Alcohol is not acting as electrophile. Can alcohol act as an electrophile? Because oxygen is having what? Lone pair of electrons. But once a proton adds to the alcohol, it becomes deficient of what? Electron. So, what can you say? Protonated alcohol acts as electrophile. Alcohol acts as what? Nucleophile, but protonated alcohol acts as electrophile. So, both these points are clear. Alcohol acts as a nucleophile, and next is protonated alcohol acts as electrophile. When this reaction is happening, the bond cleavage taking place is between carbon oxygen. That is, when a proton adds to a alcohol, during the reaction the bond cleavage takes place between whom? Carbon and oxygen. So, all these points are very important when you are going to study chemical reactions. That is, when it acts as a nucleophile, the bond cleavage is taking place between what? Oxygen and hydrogen, and in case of a protonated alcohol, the bond cleavage takes place between carbon and oxygen. So, is it clear? So, alcohol can act as a nucleophile, protonated alcohol can act as electrophile. When it acts as a nucleophile, the bond cleavage takes place between oxygen and hydrogen, and when the protonated alcohol is acting as an electrophile, the bond cleavage takes place between carbon and oxygen. Both these things you come across in chemical reactions. Next is the alcohols act as Bronsted acid. Now, what is a Bronsted acid? You have already studied this in the chapter equilibrium in class 11th, Lowry-Bronsted concept of acid and base. According to Lowry-Bronsted concept, an acid is a substance which can give a proton and base is a substance which can accept a proton. So, alcohols act as Bronsted acids. See this reaction. This is a base. I am writing here ROH, you are getting BH plus plus RO minus. Okay. Here who has given the proton? This alcohol has given the proton. So, this is what? Acid. And who is accepting that proton? H plus, who is accepting? The base is accepting, B is accepting. So, this is what? This is known as conjugate acid, and this is known as what? Conjugate base. So, is it clear? So, alcohol acts as Bronsted acid. When an acid is giving a proton, then what you are getting, that is known as what? Conjugate base, and when a base accepts a proton, it is converted into what? Conjugate acid. Is it clear? Now, this conjugate acid gives H plus, so you get what? A base, and this conjugate base is accepting a proton, so you get what? Acid. So, alcohols act as Bronsted acid. Now, see here, phenol is also a Bronsted acid. Phenol is also a Bronsted acid. Why? See here, this is phenol. So, this is giving H plus, you get what? O minus, wait, yeah, O minus plus BH. So, this is what? Base, this is acid, this is conjugate base, and this is conjugate acid. So, what can you say? Phenol also acts as what? Bronsted acid. Alcohol also acts as Bronsted acid. So, both these concepts are clear. Now, let us compare the acidic character of alcohol and phenol. Phenol, see here, this reaction I have written. Now, next you see here, alcohol gives you RO minus plus H plus. Next step you see here, RO minus plus H2O gives you ROH plus OH minus. Okay. So, in this reaction, which is the acid? Who is giving H plus? H2O. So, this is acid, and who is accepting that H plus? RO minus. So, this is what? Base. So, this is conjugate acid, this is conjugate base. So, alcohol dissociates to give you, this is RO minus is known as what? Alkoxide ion. Alkoxide ion you are getting. So, this alkoxide ion is reacting with water to give you alcohol plus OH minus. Now, this already you know, if an acid is strong, its conjugate base will be what? Weak. Both cannot be either strong nor weak. So, here you see, if I say this acid is weak, the base is what? Strong. The conjugate base is strong. Now, how can you say that this conjugate base is strong? If this conjugate base was not strong, it would not have accepted a proton from what? Water. That is, water is losing a proton and who is readily accepting it? This alkoxide ion or RO minus. That means RO minus is what? A strong base. So, if this is strong, automatically alcohol is what? A weak acid, because both cannot be strong nor both can be what? Weak. Since alcohol is a weak acid, alkoxide ion is what? A strong base, and the strong base is easily accepting what? A proton from water. So, from this what can you conclude? Alcohol is a weaker acid than what? Water. So, is it clear? Alcohols are weaker acid than water. Alcohol is an acid because it gives a proton, but when we compare alcohol and water, water is a stronger acid than alcohol. Why? Because the alcohol, when the base formed from alcohol, that is alkoxide ion, it is easily accepting a proton from water. From this we can conclude that alcohol is a weaker acid than water. So, is it clear? Alcohol is a Bronsted acid, then because it gives a proton. But when we compare alcohol and water, alcohol is a weaker acid than water. Why? Because the alkoxide ion, which is the conjugate base of alcohol, it easily accepts a proton from water, from which we can confirm that if the base is strong, the acid, that is alcohol, is weak in nature. So, is it clear? So, water is a stronger acid than alcohol. So, this much is clear. So, alcohol can act as a nucleophile due to the presence of lone pair of electron on oxygen atom. When it acts as a nucleophile, it gives electron to an electrophile, and during that time the bond cleavage taking place is between oxygen and hydrogen. Then next is protonated alcohol acts as an electrophile, and at that time the bond cleavage is between carbon and oxygen. Next is alcohol acts as what? Bronsted acid, and phenol also can act as a Bronsted acid because they can give a proton. Now, next thing you have to clear is, when we compare alcohol and water, water is a stronger acid than what? Alcohol. Why? Because the base formed after alcohol giving a proton, which is known as alkoxide ion, it when reacts with water, it easily accepts a proton from what? Water. So, if the alkoxide ion is easily accepting a proton from water, means that it is a strong base. So, if it has to be strong, means its conjugate acid is what? Weak. And who is the conjugate acid of this base? Alkoxide ion, that is alcohol. So, alcohol is a weaker acid than water. So, these are the important properties of alcohol which we have discussed here. So, in next class we will discuss the remaining properties.